So I hope all of you understood the first question from the exercise 8.2. So today we start the second one, and the second question is given like in this way. If you see here, ABCD is a rhombus and PQ, R and S are the midpoints of the sides AB, BC, CD and DA respectively. So that the quadrilateral PQRS is a rectangle, we need to prove here. Isn't it? So now here diagram is not given here, so that's why we have to draw on this one by our own. So that's why if you see the diagram first, if you see the diagram here, the diagram is this one. According to our question, ABCD is a rhombus. So what is the property of rhombus? All sides are equal, but the angles are not 90 degrees. So in this case, you see here AB, BC, CD, DA. ABCD, this one is a rhombus we consider, and in this rhombus, according to our question, P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, as well as S is the midpoint of AD or DA. Is it clear? According to our question, we drawn this diagram here, and now what we need to prove here? The quadrilateral PQRS. So if we join these midpoints, P to Q, Q to R, R to S, S to P. Now this one is a quadrilateral here we get. And this quadrilateral PQRS we need to prove a rectangle. To prove rectangle, first of all we have to know what is the characteristic or what is the property of rectangle. The rectangle properties are the opposite sides are equal and parallel first of all, and each angle is here how much? 90 degree. So out of this four angles, if we prove 90 degree, as well as if we prove the opposite sides are parallel and equal, any two sides, then our proof is complete here. So two things we have to do here: opposite sides are equal and parallel we need to prove, as well as we need to prove each angle is, or any one angle is 90 degree. Is it clear? Okay, let's start now. So now here, as you see here, first of all, in this side, if you see in this side, ABC, this one is a triangle. If you draw this one separately, the diagram is drawn here, you see, this one, ABC, separately here, this part. That means here AC and BD are what? These two are the diagonals, isn't it? So including this diagonal, this ABC triangle separately we drawn here, and in this diagram you see here P and Q are what? Midpoints. If P and Q are the midpoints in this triangle, then one property we know, using the midpoint theorem, what we can say? PQ is parallel to AC, easily we can say, because in our midpoint theorem we know if we join two midpoints, then whatever the side we get, this side is always parallel to the third side, isn't it? As well as one more property we know, one more condition, which one is PQ length is half of the third side. That means this third side is AC, here half of this is, isn't it? So that's why here the first one is written, if you see in triangle ABC, P and Q are the midpoints of sides AB and BC respectively. AB and BC. So according to our midpoint theorem, what we can say? PQ parallel to AC. That's why here written PQ is parallel to AC, as well as the length of PQ is half of AC. Understood this one? Okay. Now we put this one is equation number 1. After that, now if you see the next part, so another triangle here again, if you consider the triangle is ADC. If you see the triangle now, ADC. Another triangle is here, isn't it? So if we consider this triangle now, and as you see here, this one, ADC. This one is a triangle here. And now in this triangle ADC, S and R what? Are the midpoints. If S and R the midpoints, again we apply the midpoint theorem property. So what we write? If these two are the midpoints, then we can write RS is parallel to AC, as well as the length of RS is equal to half of AC. So this one written here. Same thing. So in triangle ADC, R and S are the midpoints of CD and AD respectively. So therefore, what we write, RS parallel to AC, that means this RS is parallel to AC, as well as RS equal to half of AC. I think all of you understood this one. So we put this one is equation number 2. So now from 1 and 2, from these two equations, you see here, in this diagram, it is more comfortable in these two diagrams. If you see here, SR parallel to AC, as well as PQ parallel to AC. Already we discussed this type of parallel lines in our last class. If PQ is parallel to AC, as well as AC is parallel to RS or SR, so from here what we can say, this PQ line is also parallel to RS, is not it? So that's why here written, if you see, from equations 1 and 2, we obtain, what we obtain? PQ parallel to RS. That means this PQ is parallel to RS. And if you see the right hand side part here of equation 2, half of AC is here, as well as in equation number 1, half of AC is here. If the right hand sides are equal, that means the left hand sides are also equal. So that's why here we write PQ equal to RS. Is it clear? So now here, from these two conditions, what we get? The opposite sides are parallel and equal we get. So that's why here, if you see this one, what we get? Since in quadrilateral PQRS, so PQRS separately here drawn, and in this PQRS, PQ equal to RS, we get here, you see PQ equal parallel to RS, as well as PQ equal to RS. Both the conditions are we get. So from these two conditions, what we can say, this PQRS is a first of all quadrilateral, and here one pair of opposite side is equal and parallel, is not it? So therefore this quadrilateral is known as parallelogram. The property of parallelogram is what? Opposite sides are equal and parallel. So one part is proved here. Is it clear? So one part is proved here, opposite sides are equal and parallel, we proved here. And the next part is what? Any one angle, if we prove here 90 degree, then our proof is complete. Is it clear? Okay. Now again, if you see the next part here, again we drawn this one here, A, B, C, D, whatever the rhombus given to us, and P, Q, R, S are the midpoints here, isn't it? And here the diagonals are we drawn AC and BD. So now here what written? Let's see. Let the diagonals of rhombus ABCD intersect each other at point O. The diagonals, one diagonal is AC, another diagonal is BD. These two intersect at point O. This one is denoted by O. Now here, one more thing here, we put some names like this PQ intersect by BD, so that's why this one is denoted by M, as well as this one is denoted by N. So now just we have to take this small quadrilateral, which one is O, M, Q, N. This one we have to consider. In this case, very interesting this one, you see, PQ is parallel to AC according to our midpoint theorem already proved, is not it? If PQ line is parallel to AC, that means here we can say MQ is also parallel to ON, is not it? Since PQ is parallel to AC, so the same lines here, so that's why MQ is also parallel to ON. So that's why the first one is written here. You see MQ parallel to OM. As the condition is why we get this one, because PQ is parallel to S. Similarly, the another one you see here, QR. QR is parallel to BD, isn't it? If this QR is parallel to BD, then what we can say? QN is also parallel to OM, isn't it? So that's why the second one written here, QN is parallel to OM. So from here what we can say, the opposite sides are, because QN parallel to OM and first one is MQ is parallel to OM. Since the opposite sides are parallel in this small quadrilateral OMQN. So if opposite sides are parallel, then what is the name of this small quadrilateral? The name of this small quadrilateral is parallelogram. OMQN is a parallelogram. So one thing we know, in case of parallelogram, opposite angles are always equal. So that means this OMQ angle is equal to ONQ, as well as MON, or whatever we write NOM is angle is equal with MQN. These two angles are equal. Isn't it? Now one more thing here. In case of rhombus, when the diagonals are intersect, the angle whatever we produce, the angle is always 90 degree. We know this one, isn't it? So that's why here written, if you see angle MQ and NOM already proved, PQ and NOM already proved this one, isn't it? This one from where you get, you know, because MQN is equal with NOM. MQN means also we can write PQR, isn't it? So that's why in place of MQN we write PQR. NOM is same. So that's why here the second part, whatever we discuss, the angle, the diagonal bisect or intersect each other, the angle create here 90 degree. Reason behind the condition is here written, diagonals of a rhombus are perpendicular to each other. Perpendicular means what? 90 degree. So that's why this one is 90 degree. So if NOM is 90 degree and you see here PQR is equal with NOM, so that means in place of this NOM, what we can write? We can write 90 degree. So ultimately angle PQR equal to how much we get here? 90 degree. So that's why we write here angle PQR equal to 90 degree. Is it clear? So if angle PQR equals to 90 degree, that means here opposite sides are equal and parallel, already we proved, and now here we prove one angle is 90 degree. From these two conditions, what we can say? Easily we can say here PQRS is a parallelogram having one of each interangle as 90 degrees. So that means here PQRS is what? PQRS is a rectangle. Is it clear? Opposite sides are equal and parallel, and one interangle is how much? 90 degree. So here we complete the second one here. I hope all of you understood this question, isn't it? So you have to copy this question properly. In our next class, we start from question number 3. Is it clear? Okay. Thank you.